members. Here I am with the fourth part. In that part, I'm gonna show you how you can quantify the amount of materials which will be required to execute the project. Okay, as you all know, at the very beginning of the project, I created two parameters. One was the concrete location, another was the river location. These two parameters, they will play a pivotal role in order to quantify the materials for this entire project. So keep watching. Oh, all right, the software has been opened, as you can see, and here in the schedules and quantities option, let me right click over it, new schedule and quantities. At first I want to quantify the amount of concrete uh, over the foundation. So the structural foundation, here's the option, and click OK. And what type of parameters there will be? I want to define the volume, the concrete location, that parameter. Do you remember that parameter? I created it at the very beginning of the project, so I added that parameter. And now let me get the type, the family type, family and type. Okay, add this one as well. So here the schedule for the foundation, but the family and type, I want to add this parameter as well, and I want to keep it up. Let's see whether can I modify it a bit more or not. Type, yeah, here we go. Now I want to find out a grand total. I mean, how much amount of volume will be required to accomplish the entire foundation work. So I am willing to sum up all these volumes. Let's see whether we have any option for this. That formatting, if I choose the volume, then no calculation, calculate total. Grand totals. Let's see, does it work or not? So here's the grand total. I mean, how much amount of concrete will be needed to complete the foundation works. And you all know, beneath the foundation we gave a layer of concrete. It was a 100 millimeter. That layer had a thickness of 100 millimeter, and I want to quantify the amount of concrete I used there. So let me scheduleize another sheet, and it will be floor, right? Because these 100 milli concrete layer, they lie in the floor category. I get to find out the volume. Concrete location, and here's the type. The type will be kept in the top. Then formatting filter equals to, okay. The volume, calculate total, grand totals. Let's see now. Yeah. You see that parameter I created at the very beginning, though I have repeated that same word for 1,000 times. This parameter, concrete location, is helping me a lot. Another parameter I added, I don't know whether you remember or not, or that was the river location. This parameter, it will also help me when I will quantify the amount of rivers for the project. Actually, it was a structural modeling, and the entire model, I consider two type of materials, of the concrete and the steel. So in that sense, the material quantification report I'm making right now, it seems pretty easy. All right, let's try a harder one. I mean, a complex one. And this would be the quantification of the stair. So where's that stair option? Here's the stairs. So of course I get to choose the concrete location first, then the type of family. Okay, and put it at the top. And what else? Actual number of riser. This parameter, it will help me to figure out the volume of the riser, or the area of the riser, and that parameter as well, actual riser height, actual tread depth. Okay. Okay, four type of uh, stairs there was, but I made a mistake. As you can see, there were four stairs in that modeling. As you can see in the 3D model, 1 2 3 4. So four stairs, but this is supposed to be the stair on grade. This is stair on first floor, stair on second floor, and stair on third floor. But what I did here is really annoying. I mean, there will be stair on grade, then stair first floor, second floor, third floor. By the way, hope you can understand what am I trying to say. I just made a little mistake when I made that filterization, and begging your pardon for this. Please forgive me. I feel tired of saying that word, forgive me, begging your pardon. Anyway, now the thing is, I have to figure out the volume of the entire uh, stair, and as you can see, I have tried to oh I tried to add some dimensions over the stair so that I can calculate the required volume easily, and I will try to calculate that volume through watching that figure. So WT, okay. This is the tread, and this one is the riser. So the riser has a height of 184.21 millimeter, and the tread, it has a depth of 304.8 millimeter. Anyway, this is supposed to be the actual depth, so I will consider this one when I will calculate the volume or the area, right? Okay, and before that, let me check the project unit. And the project unit, the area, I am willing to keep it at meter square. Here the meter square, the area. The volume will be in meter cube. Okay, it seems cool. Now, that window, let me go to the field option, and I suppose to create a new parameter uh, inside that schedule fields, and that parameter will help me to figure out the volume of that riser. So here, riser volume. Sorry, I make a lot of typing mistake. The type. Let me choose volume. Okay, at first let's try to figure out the volume of a single riser, and anyway, at first let me figure out the area of the riser, the cross-sectional area, of course. Cross-sectional means this area, right? Riser area, and it will be actual riser height times actual riser depth. Okay, here's the riser area, and using this parameter, it will be pretty easy for me to figure out the volume of the entire structure, entire staircase. Okay, let me go to the fields again. Now it's time to create another parameter which will figure out the volume. And in the type, let me keep it to volume riser area. Okay, times what? In the figure, I mean in the plan, in the foundation plan, I saw that the stair, it had a landing width of 1 meter. So let me put it 1. Okay, it's not showing any result because I want to set it as number. Previously I set it as volume, that's why it didn't work. That means this parameter is worthless. Let me delete it. Another parameter, and it's going to work, I hope. Riser volume, number, percentage of actual riser height times actual riser depth. what am I doing? Have area here. Okay, uh, at first uh, you need to make it unitless. In order to do so, I get to divide it by 1. 1 implies it will get divided by 1 square meter to make it a unitless figure. Then I think I have some problem in the unit. Let me set the unit again. The length is supposed to keep it meters. Yeah. So what the hell? I get to make it again. Riser volume. Riser volume. And number or riser area divided by 1 times this one. It's supposed to be the breadth of the landing or the width of the landing, however you denote it. It's up to you. Okay, let's try this one and see what happens. It worked, you see. It worked greatly. And you all know things are not that easy over here. As you can see, this is the dimension of the riser depth, of the tread depth, and this is supposed to be the dimension of the actual riser height. And below that there are some other concrete portion. You need to consider them when you are trying to quantify the materials, right? So as you can see, I took the dimensions. Okay, so let me go to the riser volume option again, and through watching this thing, they were supposed to be in millimeters. Okay, for the convenience I jumped back to the previous unit again. Here's okay, so we have 20 risers. There will be multiplied another parameter which will be actual number of risers, and you see it's supposed to be a rectangle which has an area of 300 times 184.21, and below that there's another rectangle which another triangle which has half of the area of that rectangle. So this triangle will be considered as a rectangle, but it will be multiplied with half. So this is 1, this is half, which means times 1.5. Okay, and you can see there's another portion, I mean this small portion, and I want to consider them as well. So it will be um, come on. 50.48 times 304.0 times times 10 to the power. Let's see how does it work. Okay, here's the area. Here's the volume of the concrete. Let me go to that riser volume option again. Let's see the unit format. Okay, if you have any confusion, then let me explain that formula again. Let me start from the very beginning. This is the area of the riser. Then for the requirement, to fulfill the requirement of Revit, I tried to make it dimensionless. So I divided it with 1 square meter. Then that one, it belongs to the breadth of the landing. It was a breadth of 1 meter. That's why I added that one. And we had 20 risers. So this is supposed to be the actual number of the risers. And that 1.5, how did it come? This 1.5, it implies two things, one rectangle and another triangle. So one for that rectangle, as you can see, 300 times 184.21, and 0.5 for that triangle. And that triangle, it has a height of 184.21 and has a base of 300. Okay, that's why there came 1.5. And there was another small rectangle, as you can see, which has a height of 50.48 times 300 millimeters, and they both were in millimeter. I wanted to bring them in a meter. That's why 10 inverse 3 times 10 inverse 3, which implies 10 inverse 6. That's why I added that extra 10 inverse 6, that big number. Not big, smallest number in a sense. Okay, and now let's find out the grand total riser volume. Calculate total. There's the grand total. Okay, so we supposed to need 6.799 cubic meter of concrete right here, and that column doesn't have any purpose, so why don't I hide it? Okay, I hide that column, and let me see, can I add any parameters right here? It will be in meter cube, so I get to specify that thing. Right, that meter cube. Let's see, do we have any option? Can I add any string? No, these are numbers, so you are not allowed to add any string. I hope the engineers they can understand that meter cube. Why does it, I mean, what is the purpose? It denoting the quantity of the concrete, right? Okay, so we have some other structural members. I have already created the quantification of three structural members: the foundations, the stair. Hell, anyway, the floor schedule, I mean, that 100 millimeter layer of concrete, I schedulized that one, and then I schedulized the stairs. I mean, how much amount of concrete will be required. Then I schedulized the foundations. Okay, that's it. All right, I have showed you the quantification process of the concrete. Now it's time to quantify the rebars. I mean, the quantity of rebars. And rebars, they are quantified as weight. I mean, the weight, that measure is being considered. Okay, let's get it started. The schedule, new schedules, and from the category option, I'm supposed to choose the structural rebar. At first, I created another parameter which I named as a rebar location. That parameter will help when I will make that material schedule report. Here's the rebar location parameter. Then the part diameter. This parameter is also helpful. Then let's see whether we have any parameter for the weight quantification or the volume quantification. This parameter, reinforcement volume, it will be helpful. And what else? Report location, report diameter. Okay, let's see. Get to set the format. It will be in millimeter. 0. Okay, these are the number of the rebars. Okay, I get to filterize if your rebar location equals to, I am interested of the footing rebars, so I choose the footing rebars option. I can select OK. Yeah. So here's the list of footing rebars. And I want to keep it centimeter, cubic centimeters. Okay, now let's figure out the grand total, the formatting, rebar volume, calculate total, appearance, all right. This is the volume of the rebar, and you can ask Google the unit weight of rebars. Here I have, let me ask Google unit weight of steel. Bad luck, no internet is available right now. All right, if I multiply the unit weight of steel with that value, with that grand total, then I will figure out the total weight of steel which will be required for the footing portion, right? And also regarding these all right, let me take a look. Is there any more option we can? Okay, bar length is also important, because when the reinforcement will fabricate it in the real world, I mean in the field, then it's very important that bar length. So I get to add it as well. So here's the bar length. All right. For the bar bending schedule, this length is important. That's how you can make your rebar quantification report. Let me rebar schedule. All right, this is the rebar schedule of footing. And following that exact same way, I will make rebar schedule report of footings, columns, beams, shear walls, slabs, all these structural members. As I already mentioned before, I don't want to enlarge the length of this video that long. That's why I will do all these things by myself. Also, I will do the concrete schedule report as well. I'm gonna do all these things by myself. Till then, goodbye.